Thank you. Right, we're looking at the main parts of a nuclear reactor. There's 4 or 5 main parts, and the diagram that I gave you the last day is slightly incorrect, so we'll go through it again. First thing you need? Fuel rod. Fuel rod. Big rectangle like that, we're going to put in 3 fuel rods. If I want to control the rate of the reaction, so basically neutrons come in here. As they hit individual atoms in there, they make the atoms split up into 2, and as a result other neutrons come out and hit other atoms. Some of the neutrons come from there to there. If I want to prevent neutrons going from there to there and initiating an even greater reaction, what do I have to do? Control down in control rods. So basically over each of these you've got control rods, and as those control rods go down, it's like a big sleeve that goes over the uranium. They prevent the neutrons from going from there to there. So you're controlling the rate of the reaction, right? Now the mistake I gave was the last day when I said the moderator, which was heavy water, remember, which is deuterium, I said that was all around like that. And then I had to put the coolant in around, surrounding that. The moderator actually is a little bit more straightforward. It's just another, basically a bar that goes in between. And you don't move that moderator, it stays there. Now it contains heavy water, or instead of heavy water, what's another type of moderator you could have? Heavy water. Called a heavy water, or there's one other thing called graphite. So either of the two of them. So let's label these guys. What did we say the green guy was?
I'm like in pencils.
Yep, same idea.
Green is control rod.
Green is the control rod. C-O-N-T-R-O-L. Red?
Moderator.
And the black?
Fuel rod.
Function of the fuel rod is to supply the uranium. Function of the control rod is to what?
Control the reaction.
Control the reaction. Control the rate of the reaction. And the function of the moderator?
Slow down the neutrons.
Slow down the neutrons. Why?
So they produce further fission.
Yeah, so you need to get the whole sentence. To slow down the neutrons so that when the neutrons come from here to here, they won't zip straight through the next uranium rod. You've got to slow them down in order to be captured by the nucleus. So those are the 3 main parts of the nuclear reactor. And apart from that, then you've got basically the superfluous bits. What would go around it? You've got lead shielding going the whole way around it pretty much. And that's to prevent any radiation getting out. Now, where do you think the cooling will go?
Inside.
Yeah, so the coolant is now, if we had a different color, we'll put it here. Basically there's coolant because the neutrons are zipping through the water, so they're moving really quickly, and therefore, or sorry, it's not even water. Remember we said some type of oil?
Shouldn't it be hitting off the atoms in there then and slow them down?
Shouldn't.
It should, like, out the oil.
It will, yeah, I suppose it would slow down very, very slightly going through the oil, but not enough to prevent it initiating more fission over here. So it probably would slow, it would have to. If the coolant is gaining energy, yeah, then the neutrons would have to lose a little bit of energy, but obviously not enough. So the coolant heats up. You want to transfer that heat, ultimately, where is that coolant going to go?
To a turbine or something.
Yeah, to a turbine, it's going to probably go to water. So water is not going to go outside, and you have some sort of a system like this outside. So the coolant will go through that, and while it's going through that, it's coming in contact with water. The water heats up. What happens to water when it heats up?
Goes to steam.
Goes to steam. What does the steam do?
Turn it.
And what does the turbine have?
A magnet in the coil.
A magnet in the coil, and it moves one relative to the other. Okay? So basic components of your nuclear reactor, 4 or 5 main parts, you just have to name one. Diagram doesn't have to be great. Let's take a look at one type of coolant here. So we can switch over Shane to the computer screen at this stage. This is my uranium. Now, what did we say was uranium? What type of uranium do we need for nuclear reactions? 235. What was the other type of uranium? 238. And what percentage of uranium is 235? 0.7%. Now, from there you come on to the nuclear reactor itself. Main components, they're missing one component here. What do you think these guys here are?
Moderators.
Nope.
They're the yolk.
Fuel rods.
Fuel rods.
U238.
Those are all the uranium-235. So those are the fuel rods. The blue things?
No, there's no control rods.
Moderator.
They
That's
go
the
up and
moderator.
down, so therefore
Control.
control rods. So they're controlling how many neutrons come out of this guy and happen to bump into the next one.
Alright.
Right? Going all around it would be normally a coolant, but what are we missing here?
Moderator.
You're missing the moderator. So normally you'd have a moderator in there to slow the electrons going from one to the other. Okay, so you don't have the moderator, but nevertheless, we'll bump it all up, we'll fire a couple of neutrons in there, and you're getting a reaction, but nothing is going into any of these other columns, so the reaction is fairly sustained. Whereas if you drop the control rod, let's reset it, drop the control rod, so we want much more heat being produced, and there's a graph here, we can put the graph up, that shows the energy being produced. Fire a neutron, and now because there's no control rods up there, anything that comes out of one can go into another, and therefore you can get a complete, that guy there is temperature, so the temperature is rocketing way up. And what happened in Chernobyl, I think it was the control rods here which melted or went on fire, and as a result, they disappeared completely, and therefore this thing pretty much went out of control. Okay, so that'll do for now. That's the nuclear reactor. We'll hold it there, and we'll take a look at something else in a minute. So you're stopping that. Hit record. Just before we move away from nuclear reactors altogether, just to put, Louise, the reactor in context. Remember, we tried to explain how do you get nuclear power from a nuclear reactor. So when we were studying, what we took the diagram of was just this small little bit of it there. That was the nuclear reactor containing the uranium, which was the fuel rods, the control rods, which were sliding in on top of it, and then the moderator, which was the heavy water. They're basically just slabs containing heavy water in there. And we said around that you have the coolant. So the coolant goes all around, and as it goes up here, fuel rods presumably are up here, it gets hotter and hotter and hotter because you're getting fission taking place all the time up here. So particles are zipping out, and as they do so, they zip into the water, this is probably not water, it's certainly some sort of a coolant, so some sort of an oil. And as the particles zip into the oil, they make the oil particles move much more quickly, and that's basically what temperature is. So now, this oil coolant is much hotter here than it is at the bottom, so you want to use that to somehow drive a turbine. So you pump that coolant around, and in this case, it's going in cold, goes in here. As it gets to the top, it gets hot, so you keep pumping it. You have some sort of an escape valve here, a safety valve, I would imagine, of some description. And here, what you want to do, we said, was heat water and make the water boil and produce steam. So as it goes in here, it heats up the water turns to steam turns a turbine. Somewhere you've got a magnet and you've got a coil, and in there, as a result, you've got electricity. And basically, we said electricity, what you're inducing is an EMF. Remember, it's an EMF, and the EMF produces a current. So this electricity is a very vague term, it's not really scientific. What you're causing here is a potential difference.